watching this video to find out how to find slant asymptotes, I suggest you pause the page, write this down because we're going to be moving on. We've already written this down, so you can pause this, and then we're going to apply it right now. So we're going to talk about a case where the numerator is just 1 degree larger than the degree of the denominator. And when it says p of x and q of x, I will explain to you what that means. So let's say f of x, our function, is equal to p of x over q of x. And in this particular case, I'm going to say p of x is 2x to the third minus 3x plus 5. And then in the denominator, actually, you know what? We'll say cube, we'll say squared, make it a little easier. 2x squared minus 3x plus 5. And in the denominator, I want you guys to write x plus 2. All right? So right here, p of x is 1 degree bigger than q of x. What's our m value? 2. What's our n value? 1. So if you notice, it's just 1 degree bigger. You don't know where the 1 came from. This is x to the first. All right? Remember our first example was, if you're wondering what things are, you have a times x to the n plus the dot, 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 over b x to the n plus dot, dot, dot. That's what we just did. Okay? And we're comparing the n value to the n value. And ours is just 1 degree different. So this one actually has 2 asymptotes. Okay? One of them is a vertical asymptote. At x equals -2, you will see what's known as a vertical asymptote. So in your journal, you can say, okay, we still have to know how to find the vertical asymptote, because if you plug in a -2, it makes that denominator equal to 0. The next part, though, is we have to use long division or synthetic division to find the slant asymptote. So that's what we're going to do right now. Here's how you would set up this equation using long division. Okay? The divisor you would put as x plus 2. All right? The dividend you would put at 2x squared minus 3x plus 5. All right? And the quotient, whatever you got up here, the quotient, not counting the remainder, that would end up being your slant asymptote. Okay? So whatever you got here would be your slant asymptote. However, synthetic division is a lot easier to do than long division. So we're going to practice synthetic division.
Is this the synthetic one?
This is going to be the synthetic one right here. So I'm going to write down the words synthetic division. Okay? Now there is a rule for synthetic division that you have to follow. Alright? In the first column, we're going to place, notice we have x squared, right? So we're going to lead out with our x squareds. Then we're going to follow it with our x to the power of 1, right here. And then we're going to finish it with x to the power of 0, even though you can't see it. This 5 is technically, you could say 5 times x to the power of 0. So you have to do them in descending order. How many x squareds do we have? 2. So you put 2. How many x to the firsts do we have?
3.
Close. Be more specific. -3. And how many constants do we have at the end? 5. So I want you to pay really close attention here. The 2, the -3, and the 5 are simply dropped down. Those coefficients, all right? Just drop them down. Right here, if we're dividing something into something, we're checking to see if it's a factor, right? That's basically what we're checking to see. Is this a factor of this right here? You're not going to put the factor in this part right here. You're actually going to put what's known as the root. All right? If this is the factor, the root will be known as a -2. So in synthetic division, it's always going to be the opposite. So make sure, if this says x plus 2, right here you're going to put a -2. Conversely, if I changed it, don't change it. If I said x minus 2, then you could use a positive 2. All right, so let's review synthetic division. The very first thing that you do, first thing you're going to do is you're going to drop down the 2. So you're going to pull the 2 down. Then you guys remember what we do? Multiply the negative 2 times the 2. Get a negative 4. So negative 2 times 2 is a negative 4. Then what are we going to do with the negative 3 and the negative 4? Combine them together and get negative 7. Then we're going to multiply these guys together. Negative 2 and negative 7 get positive 14. Add them together, get a 19. Let me explain to you what this 19 represents. This 19 represents the remainder. That represents the remainder, that 19. Now, what did I tell you guys about the remainder when we were doing this? Do we have to worry about the remainder? Scroll up, right? You can what? Ignore the remainder. So what I'm going to do right now is I'm going to ignore this number. I'm not going to worry about it. The only numbers I'm going to worry about are this what? This 2 and this negative 7. This is actually the number of x's that go into it. This is actually the number of x to the zeros, or constants, that go into the number. So my slant asymptote, I found it. Let me show you how to interpret these two numbers. Your slant asymptote is where y is equal to 2x. That's how many x's you have, minus a 7. Your slant asymptote is actually a line that's slanted. Crazy. That's why they call it a what? Slant asymptote. Because it's not vertical. It's not perfectly horizontal. It's what? It's slanted. Okay? So what we're going to do now is we're going to check this. If I sound a little angry in the video, it's because certain people weren't paying attention when they needed to be paying attention. But I'm not going to mention any names. Protect the innocent. So, by the way, go to y equals right here. Okay, alpha y equals enter. Alright, and you guys have the equation written on your page somewhere. We just talked about it. So what's going to be in the numerator? What's the equation we're going to literally write up here in the numerator? 2x squared minus 3x plus 5. Thank you so much. And x plus 2? Okay. And what did we already say we were going to have a vertical asymptote at? Negative 2. The question I asked was vertical. You were jumping to the other part. Okay?
Yeah.
So we're going to have a vertical asymptote. Take graph. Should be an interesting graph. Looks a little different. Okay? We said right here in this graph, we said there was going to be a what? A vertical asymptote right here at a what? Negative 2. So there, right there, if I zoomed out, you would see the graph would get closer and closer. It would never cross. What did we say our slant asymptote was at? Now you can say it.
2x.
There we go. So right, watch this. 2x minus 7. And hit the graph button. Watch. You're like, well, that doesn't make a whole bunch of sense. I'm like, how do you know that's correct? Now watch what happens. Hit the trace button, everybody. Actually, hit zoom 6 so you can look at it a little bit more zoomed out. Zoom 6. Ooh, now you can see it a little bit better. Now, everybody hit the trace button. If you hit the trace button, you'll see a little cursor. Follow it. Now, go to the right and follow this graph. Make it go way far to the right. Okay? So get it all the way up here in this corner. It's a little bit easier for you guys to maneuver this than me because I'm on a computer screen. Now, right here, I want you to press enter. Now, what have I done? I've gone to a different part of the graph. Look how the slant asymptote and the graph are getting what? They're getting closer and closer together. If I were to continue this process, everybody, there's your equation right here that you can see that we're dealing with right here. So if I zoom in to a different part of the graph, which is way over here, all the way till it stops. All right, so if I zoom into this part and hit enter, once again, you will see the what? You'll see the slant asymptote and the graph get closer and closer together. All right, so I realized the first time you looked at the picture, you're like, well, I really can't see that much of a difference. Okay, because it wasn't that close to the graph. But when you zoomed out, yeah, move around. Okay. So that's how you find a slant asymptote. What do you have to use? You have to use a long division or synthetic division. Okay.